Okay. So in week 2, let's go back to our class notes. All right. So we're going to spend the first hour looking at Scrum in detail. So in yesterday's class, I told you the different types of life cycles that we have. I told you guys the pros and cons of each of them. Now, because Agile or Scrum is so widely used that I know that when you get a job, you're probably going to be using Agile in your company. So that's why for the next hour, I'm going to go very much in detail and show you exactly how we do it. So everyone knows what Agile is. You know, I told you guys yesterday that Agile, it's one of the SDLCs. It's just a process that we follow to build softwares. I told you guys as well that Agile has some pros. And from yesterday's class, you know, one of the biggest pro is Agile allows early testing. You start way early on. And we know that when you start early, good things happen. You find the problems, you know, really early on, and they're very cheap to fix. Agile is also very flexible, so we can actually have changing requirements. So in fact, you know, the buzzword is we welcome changing requirements. So that's one of the pros of Agile. And the reason for this is because Agile breaks down the product into smaller little chunks. And you now do one chunk at a time. And most companies have a cycle of 2 weeks. So the idea here is, let me turn off my Skype. So the idea here is, you know, if after 2 weeks we show the customer what we've done and they say, no, that's not what I want, we haven't really lost a lot of time. You know, we can easily go back and fix, you know, the problem. So Agile has that strength. Agile also has, you know, we tend to finish on time. And the reason for this is because every 2 weeks, you know, we're kind of going into a cycle where we're doing, you know, we're repeating ourselves every 2 weeks. And after you repeat the same cycle, say for 1 month, the idea is, you know exactly what you're doing and everybody is really efficient. And when you're saving time, you're also kind of saving money. That was the summary from yesterday's class. I told you guys that Agile has, you know, it has a con. You know, one of the disadvantages of Agile is the fact that it's new. So a lot of companies, you know, they're still struggling or to understand it properly. And some people just complain. They don't really like all the meetings that Agile requires. You will see it today when we take it step by step. You will see how heavy meetings Agile has. Another con is, you know, if you're working on a commercial project and you need to know exactly, you know, an estimate on when you're going to be done and how much money you need to charge the customer, Agile might be a problem for that because Agile says, don't really, you know, there's no point sending out a BA to gather the entire requirement because from past history, we know that we're going to change our minds anyways. You know, we're not going to stick to the plan anyways. So why waste a month of having a BA do all that work? So that was the argument. They said, just take it chunk by chunk by chunk. And by third or fourth chunk, we have an idea of how long it's going to take us. Some companies do it that way, but some companies are not really comfortable doing that. You know, they need to know before they start a project. So I told you guys the way around that is companies combine waterfall and Agile together. How do they do this? They tend to do their requirement gathering in the waterfall phase. So the BA still goes out and gathers the entire requirement. Now they now carry on the rest of the life cycle. They tend to use Agile. Okay. So let's take a look at Agile in a deeper perspective, and let's break it down. In your class notes, I've given you guys what we call the Agile Manifesto. You know, what is the manifesto? The manifesto is a set of rules that was created by the founders of Agile. And they claim that if you follow everything in that manifesto, then you are doing Agile properly. Now, for a lot of you, they will not ask you in an interview, tell me an Agile manifesto. No, nobody will ask you that. So you don't really need to know it, but it's always nice, if to know where to go to if you're in a company that is struggling to do Agile. So I'm going to briefly go over the manifesto with you guys, so that you have an idea of, what the founders had in mind. The founding fathers, we can call them that. Alrighty. Sorry, my diagram is a little bit, is not straight looking. So the first principle is these guys believe that we will make the customer happy by giving the customer continuous delivery of a software. So what they mean is we'll make you happy by showing you something every 2 weeks. And that's why we have that small little chunk and chunk and chunk. The second principle is, hey, you can keep changing your mind. We actually welcome it. So you can see the word welcome changing requirement, even late in the process. To be honest with you, I don't know how true that is, but the founding fathers really believe that doing it this way, we can even change our mind, late in the process. The third principle is where the founding fathers advised us on how that cycle should take, how long the cycle should take. So I told you most companies do a couple of weeks, so that means 2 weeks. They said anywhere from 2 weeks to 2 months. That's where you should, have your repetition. The fourth one is really important, and this change, the working environment. And when you get a job as well, you will notice that there are no more departments. We don't have it anymore in IT. 10 years ago, there was a business department, there was a QA department, and they all sat together. These guys said, that's the problem. We're all building one product, but we all sat in different side of the company. We all have different groups. Of course the product will suffer. So what they said is the project team should always be sat together every day. So now you notice most companies is what we call open, is an open plan, where your entire company that makes software is just tables and chairs everywhere, and everybody can see everybody. And the reason behind that is because the founding fathers of Agile told us that's a better way to work. The next principle is to make more sense, once I've gone over the Agile with you, but they really believe that you need to give the team enough power to decide on how much they're going to do every 2 weeks. And they believe by doing that, the team becomes really motivated. Agile says a face-to-face is always better than email. And the reason behind that is they said, you're probably going to email your coworker or a BA if she's far away from you in a different department. And by doing that, you guys there's already a miscommunication, or, it takes longer to understand each other. But they think when you're right there, face to face, they think is an efficient and effective way of communicating. The next principle is also saying, don't fool yourself, guys. The working software is a measure of progress, meaning that at the end of the 2 weeks, if there's no chunk that is done yet, then we can't call that progress. And that's a different way of thinking because, in the old days, we thought, okay, well, progress is we've done 2 weeks of work or we've done 1 month of work. But they say now that if the software you've built is not working, that little chunk, then hey, you haven't done anything yet. The next principle or the next manifesto says the agile process promotes a sustainable development. What they mean here is we are pacing ourselves, at a constant pace. So that way we don't burn out, right? And because we're going every 2 weeks, every 2 weeks, every 2 weeks, and the team decides on how much work they would take on in those 2 weeks, the founders believe that doing it that way, will make everybody not tired or burnt out, which is a very, very common symptom in the waterfall. A lot of us in the waterfall in the early days is a 1 year project. So from Jan till March is a really laid back vibe. Everyone is drinking coffee 5 times a day. Everyone is chatting. Some people are coming in late because there's no pressure. Now, November, December, October is crazy because we have to ship this product and people get burnt out, so they are trying to, they want to fix that problem by doing 2 weeks cycle. Continuous attention, I'll show you that soon, how Agile does that. Keep it simple. I think this applies to anything, even the way I teach as well. When you keep it simple, people can understand it and you can get things done quicker and better. This one here, it's a little bit scary to companies, management in companies, senior management, because Agile actually says, the best architects, the best requirements, the best teams actually come from having the teams self-manage themselves. It's a really scary, I don't know if I totally believe in this, but that's what they said. They said, let them figure it out themselves. Don't put a manager to be watching them daily. No, let them figure it out. And by doing that, they will create a very good work. The last manifesto principle says, at regular intervals, always let's come together and let's reflect. Let's see what we can do better. What can we change? How can we make it better? And they think is a good idea, but for someone like me, that's why they have so many meetings. And that's why I don't like about Agile, because at regular intervals, they mean every day. You have to join a meeting where you talk about what you did yesterday, blah, blah, blah. And the founding fathers designed it that way because they think, if we meet regularly, then, we will build a better software. So that's the manifesto. Please, you don't have to memorize this. It's not required to get a job, but it's always nice to know, this is the law. The guys that founded Agile, this was what they had in mind. So back to the class notes. Now, I've been saying the word Agile, Agile, Agile. And there are actually 3 types of Agile that the founding fathers created. And the first one is what we call Scrum. And Scrum is so popular that a lot of us in the IT industry, when we say Agile, we mean Scrum because Scrum is that popular. We also have another type of Agile called Extreme Programming. And the last one is what we call Kanban. I'll quickly explain these 2. Then we're going to spend a lot of time on Scrum. And going forward, everything we're going to be doing to you guys graduate will be done using the Scrum lifecycle. So what is extreme programming? In my mind, extreme programming is exactly like the V model. I think they copied the V model and they just named it something different, right? But essentially what it means is you're pairing people up together, and that's why it's called extreme programming. Extreme programming is a process of Agile where we pair people up together. So on a project team, I might have two BAs, I might have two QAs, I might have, two architects. And the idea behind this is two heads is better than one. And hence it's called extreme. So when I saw this, I just thought right away, oh, this is the V model. It's exactly the same thing. But the slight difference here is this. The V model, you have two people on a team, but one person is kind of like the reviewer of the other person. So one person is like the boss of the other person. And they believe that's the problem with the V model. That, you've put two people together and you're making one, so to speak, micromanage the other one. So they said, okay, no, we're not going to do it that way. We're going to make them equal, where we have two people and both of them, they're not really reviewing each other's work, but they're doing the job together. So that's the slight difference between V model and extreme programming. There's a diagram I gave you guys in your class notes. You don't really need to, pay too much attention to it, but the diagram explains to you the theoretical extreme programming, so that you can have a look at that diagram. And all he's trying to tell you is just we're pairing people up together. Okay. Now, the other type of Agile that we have is what we call Kanban. And sorry, my diagram is not very clear, but what is Kanban? Kanban is a type of Agile that focuses on the people, the team members. So the emphasis is on, how much work is this person doing compared to this other person. So let me give you an example now. We are in a call center and we have 10 people that pick up the phone calls, right? So we have 10 employees. If I'm doing the Kanban process, essentially all I'm doing is I would have a diagram or a board that would have the names of my team members, and I can see how much work each person has done. So I can say maybe Ty, there's Sue, there's Taran, maybe MJ. I can see exactly maybe Ty today picked up only 3 phone calls, right? And maybe Ty has 2 more phone calls to pick up. Maybe Sue has done 5 phone calls, and maybe she has 1 more to go. Taran, the same thing. Maybe she's done all her work for today, and maybe MJ has done nothing yet. Now, the problem with this life cycle, and the reason why it's not very popular, is Kanban always assumes that the complexity is the same. Complexity of the work is the same, which is kind of hard to justify in software, because I can't really measure, is a QA's job more complex than a designer's job? Is a developer's job more complex than a BA's job? It's a little bit hard to justify. So Kanban is only used in companies where complexity is the same. We're all trying to do the same thing, and it's only a matter of numbers. It's a number game. So you find it very popular in call centers. You find it very popular in factories and places like that. Okay. So in this diagram, you can see here that this is a BA. So this is probably one cycle, one little chunk. And in that chunk, I can see the BA's work. You can see she's doing 1, 2, 3. She's done 1, 2, 3. In the programming side, there are 2 developers. I can see what this person is doing. I can see what the other guy is doing, and I can see what they've done. In the acceptance, this is testing. You can see there's Ty there, and there's maybe Sue over here, and you can see what they're testing, and you can see what they've done. So that's the idea, behind the Kanban process. Okay. Now the third one, which is the most popular one, which is the darling of the industry, which is what everybody uses today, is the Scrum. Why is Scrum popular? Scrum is a type of Agile that focuses on the product. So it's a little bit slightly different from Kanban. Scrum emphasizes on the product. And let's break it down. Let's see what exactly Scrum looks like. Now, the easiest way to explain Scrum is to first of all tell you the different team members you'll find in a Scrum team. So going forward, I'm also very bad. I call Agile Scrum, Scrum Agile. So when I use those words, please know that I mean the same thing. So in an Agile team, there are 3 types of team members that you find. The first person you find in an Agile team is a Scrum Master. And who is this person? Who is a Scrum Master? The Scrum Master is a project manager, essentially. But this person is the leader of the Scrum team. And they do a lot of things. The first thing they do is they ensure that you guys follow Scrum or Agile the way it was designed by the founding fathers. So they know the manifesto. In fact, they probably stare at it every day to measure up. So that's the first thing they do. They make sure you follow the process. The second thing they do is they are the ones you go to whenever you have any problems, you have a blockage that can't make you work, you go to them and they help you resolve that. So resolve team issues. Scrum Master is also the person that is responsible for how much work we do in each chunk, in each cycle. And you will see very shortly how they get there. You will see it. And lastly, quality. This person is also in charge of the quality to make sure that, hey, not only are we following the rules, not only are we fixing all the team problems, not only are we taking enough work, not too much, not too less, but also we're building a quality product. And lastly, they want to make sure that we finish on time. Now, because Agile is very new, the industry actually requires all the Scrum Masters to be certified. You might hear somebody say, hi, I'm a CSM. What they're trying to tell you is, I'm a certified Scrum Master. And I'm actually, myself, I'm also a CSM. I got trained, or I worked for a few years at Geosoft as a CSM. All right, the next person you find on the Scrum team is a product owner. And from that name, you can tell that this person is a business analyst. Okay? So CSM, Scrum Master, I said they are project managers, so don't forget that. Waterfall and Agile, they have different names for the same teams. So product owner is like a business analyst, and this person is in charge of the requirements. This is the person that will tell us exactly what to build. So please build me Facebook. I want Facebook to do this, to do this, to do this, and this, and this. So we call them product owners. Sometimes they call themselves POs. So you might say, oh, yeah, that's my CSM, and this is my PO. You know right away what it means. And lastly, we have the team members. And in the team members, this is where everybody else fits into. So the architects, the testers, the designers, the developers, the maintenance guys, everybody else fits into the team member. All right, so now that we know what an Agile team looks like, let's break it down. So when you join a company and they tell you, hey, we do Agile in this company, and maybe it's on a Monday morning that you join that company, the first thing you probably see is what we call a product backlog. And what does this mean, a product backlog? A product backlog is a place where the PO, which is a product owner, they go to store all the requirements. There's a place where the product owner goes to store all the requirements. And since you guys are online, I can actually show you the real deal. So I'll log into one of our systems right now, and I'll show you what a backlog looks like. Okay, so this is a tool I'll be teaching you guys how to use this Saturday. But let's quickly open up a project. So I'm going to pick up any of these projects here. Let's say 2 plugs. Okay, that's good. And if you notice on the left-hand side, there's something called a backlog. So that's what I mean. That's a backlog. So let me click on it. Now you can see now that in this company, on this project, the backlog, look at that, it has 49 requirements. So these are the things that the product owner wants us to do. So that's the starting point, the backlog. Now the next thing that you see or that happens in an Agile team is what we call the planning meeting. And what is this? What's a planning meeting? A planning meeting is where the entire team comes together and we actually break down the backlog, the product backlog. And we take each requirement at a time and we do 2 things about the requirement. The first thing we do is the PO, which is a product owner, describes the requirement to us. They tell us what the requirement is. Then the next thing we do is we size the requirement, which means we estimate how long it will take us as a team to finish that work. Now, something else I'm going to teach you now is in Agile, they really change all the names. You know, they don't call it requirement. They call it story. So in Agile, whenever we say a story in Agile actually means a requirement. So in the planning meeting, all we're doing is we're talking about stories, different stories. And a story is just a requirement. And at the end of the planning meeting, each story would have a story point. Let me show you again another example. I have here different stories in my backlog. Now you can see this little red circle in front of my stories. This is where we put the story point. And the story point can be in days, hour, minutes, 2 weeks, whatever, but it can also be a number. Let me see if I can find that. Okay, so in this company here, they use time. So it's a measure. It's minutes, hours, and days. But some companies, they don't do that. They actually use some numbers. And the number could be anywhere from 0 to 100. The number, I'll show you the cards in class when I see you on Saturday. It goes from 0, 1, 2, 5, 8, 10, 20, 40, 60, I believe, I can't remember, I think 80 and 100. And it also has infinity. And it also has question mark. Can't find my question mark on my keyboard. Oh, there we go. Okay. So the idea is in this method, we have to agree as a team on what 1 means. What does 1 stand for? Maybe 1 is the amount of time it takes my team, so 1 SP, which is story point, maybe is the amount of time it takes my team to build a very simple login page. That's what we agree on. That, okay, guys, 1 is how long it takes us to do this. And maybe that's 4 hours of work. So you now know going forward, whenever you put down, a 2, you are saying that this story that they're describing to you is twice as big as the story 1. So some teams use that style as well. There's no right or wrong way of doing it. Some teams don't like to measure in time. They like to use point, story point, and some teams like to use, the raw hours. So please don't forget, in an interview, they might ask you, what is a story point? The story point is essentially the estimate on how long it will take the team to build that little chunk. And so that's a story point. So going back to our class notes, the planning meeting, we talk about story, we size the story, and at the end of the sizing, we give the stories a story point. Now, something happens after you've done your planning meeting. We start the sprint. So I told you guys yesterday, a sprint in Scrum is the shortest life cycle, where you repeat yourself. So a sprint is the shortest amount of time you spend as a team to build a little chunk before you repeat yourself again. So in the diagram I showed you yesterday, there were 3 or 4 different wheels. So one wheel is a sprint. And I told you guys that most sprints in most companies go on for 2 weeks. Some is 1 month. Agile Manifesto says it can be anywhere from 2 weeks till 2 months. That's what a sprint is. It's the shortest amount of time where we spend to build stories. And after a sprint, we demo the work and we repeat ourselves all over again. So that's the sprint. Now let me show you what a sprint looks like. So once we're done the planning, the CSM will decide on how much work this team can do. And they have different techniques that they use to decide that. But can you see here it says create sprint? So the idea is we've planned, maybe we decide to do 3 stories from the backlog. Then we're going to create a sprint. So we've done, this team already has a sprint. See, they have a sprint here. Then you now move the story that you want to do in that sprint from the backlog, you move it into your sprint. You can see here this sprint goes on from October 24, 2017, all the way to November 7, 2017. So this is a 2-week sprint, I can tell. It looks like a 2 weeks of work. So that's a sprint. In this project here, you can see we have different sprints. So that's one sprint. This is a very big sprint. Wow, it's been going on for a long time. You can see it has a lot of work in there. So that's what a sprint is. Now, the sprint backlog. What is a sprint backlog? A sprint backlog is a dashboard that shows you 3 different things. So a sprint backlog. The dashboard, very similar to the Kanban, but now don't forget, Scrum is more about the product. We don't really care about, the people. We do care about the people, but it's product centric. So in this dashboard, we are showing 3, at least a minimum of 3 different columns that has 3 statuses about the product. The first status is to do, second status is in progress, and the last status is done. And the idea is we want to see the stories that will move through these columns. So a story, maybe on a Monday, might be in to do. Then maybe Sue takes it up. She starts testing the story. She will move the story to in progress. And once she's done with the story, she will move the story to done. So that's what a sprint backlog is. In interviews, they'll always ask you, what's the difference between a sprint backlog and a product backlog. So looking at this now, let me show you very quickly. On the software itself, this is my product backlog. It doesn't have any status because it's just a list of the stories we're going to do. Now a sprint backlog, if I go to my active sprint, you can already see even from the diagram, it has 3 columns, right? So if I click on my active sprint, there we go. This here is a sprint backlog. And in this company, they have 4 different statuses. They have to do, they have in progress, they have to be verified, which is by the QA, us, and lastly, they have done. So every day, the entire team, so right there, I can see now that this guy here, Coney is working on this story. I can see here someone called Mamta. She's a QA. Anything here is for us, testers. So I know Mamta, she's testing this story. And lastly, I can see what has been done by the team because that's in the done pile. So this is your active sprint. Okay. So at the end of the 2 weeks, actually, no, I skipped something. So every day in an Agile team, so you've seen your sprint backlog. So Monday morning, we plan the stories, okay? We start the sprint. 5 p.m., I go home. The next day I come back, I have to do a meeting that we call the daily scrum or a daily stand-up. And what is this? It's a very annoying meeting. I showed you guys my calendar yesterday. That's it. That's the daily stand-up. A meeting where, it lasts from anywhere from 10 to about 15 minutes if the CSM is very disciplined. And the team talks about 3 different things. The first thing you talk about is, what did you do yesterday? What did you do yesterday? Second thing you talk about is, what are you doing today? And the last thing you describe, which is optional, is, do you have any problems that we can help you with? Obviously, your problem has to be work-related. So don't tell them, oh, my cat died or my car's battery stopped running. They're asking you problems that is, that is tied to the project. And I do this as well every day. By 10 o'clock every morning, you can be guaranteed that I will be doing this meeting. And I think Tyron probably called me today around 10 o'clock. I couldn't pick it up because I was doing my stand-up meeting. And this is one of the problems of people that don't like Scrum. They feel like Scrum micromanages us, where every day I have to tell you everything I'm doing on a single day. So that's what we call the daily stand-up. Some call it the daily Scrum. Please know it means the same thing. Okay. It keeps going. We're not done yet. You can see the waterfall is so much easier. Just 5 steps. This has quite a few. Now, there's something called a burn-down chart. What is this? A burn-down chart is essentially how the Scrum Master measures the efficiency of the team. Now, you don't have to know this, but know that your Scrum Master is watching you. Is watching how much you're doing, when you're doing it. And the reason is not to tell you off, but it is his job to make sure that the team took on enough amount of work. So he will be checking this chart. And this chart is a chart or a diagram that is essentially story points versus number of days. That's all it is. So if we agreed to take on maybe story point of 10, maybe 5 stories, and each of them had 2 story points. So we said, okay, on this team, we're going to take on 10 story points. And if we have 10 days, because it's a 2-week sprint, that means we should be burning down 1 story point per day. And that diagram is essentially something that looks like this, where it's a diagram like this, where this would be your story point, SP, and this would be your number of days. And the idea is if your team is doing things right, you guys should burn down at an ideal rate, meaning on day 0, all the work should be done. So maybe this is 10. This is day 10. Let's make that 5. So yeah. So maybe when you guys started, you had 10 story points to do. And as you guys go along, you're burning down at a gradual pace. The CSM is looking for a few things. By the way, most teams don't burn down like this. I mean, we are not computers. We can't really burn down at a linear rate. Most of us burn down like this. Maybe it's a slow day today, nothing gets happened. Then you pick up steam, you burn down a lot. Then another slow day, nothing happens. Then you pick up steam. Most of us burn down like this. So most teams is like that. That's what you see. Now the CSM is looking for two things. It wants to make sure that you guys did not underestimate in the planning meeting. What is underestimate? Underestimate is when your team, for a work that would have taken you guys 2 days, you guys said it would take you just 1 day. So if you're underestimating all the time, you will find out that your team will never finish. So you guys would always be left with some work. So maybe your burn down might look like this, where on the last day, you still have a few more stories to go. Make this bigger. Let's make it bigger. So that's their job. They want to make sure that you are not underestimating. Now, the other thing they look at this diagram for is to make sure that you're not also overestimating. A team that overestimates would always finish on time. So you have the diagram will look like this, where you guys are done even way before Friday. You guys are done. And you now pretend to look busy. So you just sit there staring at your laptop, pretending to be busy. So the CSMs, when they see something like this in your planning meeting, they will be trying to make sure that it doesn't happen again. And when they see something like this as well, they will try to make sure it doesn't happen again. Let me quickly show you what a burn down chart looks like. I think we have reports right here. And in the report, oh, perfect, burn down chart. So you can see right away that these bars, they mean the weekends. So remember, it's a 10-day sprint. So Friday, Saturday, and Sunday, when you're not working, they will gray it out. But you can see exactly that the chart is burning down. And now there are many other different types of charts that the CSM use. But for you as a QA, I think the only one you have to know is the burn down chart. Okay, let's go back to our class notes. The next thing we have is what we call a sprint review. And what is that? The sprint review is at the end of the sprint. So let's say on a Friday, on the last day of the sprint, you need to show to the PO what you've done. Or sometimes you might actually have the customer there as well to say, yeah, let me see exactly what you've done in that 2 weeks. This is where you pick somebody on the team member, and this person will demo to the customer or to the product owner a working software. But this working software only has a chunk. It doesn't have the whole product, just a chunk of it. So we call this, some companies call it a review meeting. Some companies call it a demo. It means the same thing. And the last meeting, I know you guys are going any more meetings really in 2 weeks. The last meeting in that 2 weeks period is what we call a retrospect. And what is that? What is a retrospect? A retrospect is very similar to your daily stand-up. It's a meeting where the CSM would ask you three questions. The first question is, what worked well in the last sprint? Second question is, what did not work well in the last sprint? And the last one is, what should we start doing going forward? And the founding fathers did this because they thought by constantly talking about how to get better, they think that's how you become efficient as a team. That's how you gain speed. That's how quality is high. That's how you make the customers happy, because you guys are constantly always meeting to talk about how to be better. Okay? So that's it. That's the Scrum life cycle. This is what everybody's crazy about. And as you guys can see, there's quite a lot of meetings in a 2 weeks period. But the founding father said, hey, this makes it work. And I can probably attest to that because 60% of software companies, build their software using this life cycle. Now, going back to your class notes, I gave you a diagram that explains Scrum to you in a picture way. And there's nothing easier than that. When you see pictures, right here. So this here, when you have some time, I want you to go through this diagram and you see exactly what I just explained to you. So the backlog, so that's the product owner, they interview everybody, stakeholders, users, customers, and they get the requirement. And they put the requirement in the product backlog. They also rank it because they want you as a team to do number 1 first, then do number 2 next, then do number 3 next. So it's all ranked. Now, as a team, we might take 3 stories from the backlog and we plan those stories. So you can see the team. We plan those stories. Once we plan those stories, we're going to break down the stories into tasks because some stories, we have a few people working on it. Once we've done that, we will now start the sprint. As you can see, every 1 to 4 weeks in this company on this diagram, there's a repetition. And that's why you have this little thing going back. Then every 24 hours, there is a daily scrum or a daily stand-up where everybody needs to be there. That's the burn down chart. You can see the CSM looking at the burn down chart. He does this every 24 hours as well. He wants to make sure that you guys are actually on track. Then lastly, we have the sprint review. This is at the end, see, your finished work. So once you're done, then you have your sprint review. And that's just a demo where you show us the work that you've done. Then last but not least, you have the sprint retrospect. Okay. So I believe this diagram, whenever you have an interview and you want to quickly get ready for the Scrum or you want to refresh your mind, I think this diagram speaks 1,000 words. So that's it. That's the whole popular Scrum. If you do co-op with us, then you see it in action. But if you don't do co-op with us, any company you join, I can guarantee you that is the same thing they would do. So if you have any questions, please, you can ask me. Taran, I think I muted you, but if you have any questions, you can send me a text, a chat, and I'll see it. Okay, so the next topic, since we're done the Scrum, it's what I call the test design techniques. And this topic is what's going to make you all different from each other. And what do I mean by that? A QA is measured by how quality or how good of a quality their test is. Anybody can run a test once it's been documented. But thinking about the test, it's where really, really makes you stand out. Now, the good news is, before thinking about the test, we have different techniques that helps us think about those tests. And I'm going to explain the first two techniques we have is what we call the black box technique and the white box technique. The black box technique, from the name, let me draw you a diagram of a black box. From the name, it sounds like, okay, how do we draw black box? This is looking more like a green box, but I think you get the idea. Okay, good. So a black box technique is essentially a technique where, as a QA, you focus on what's going into the software, which we call input, and you focus as well on what's coming out of the software, which we call output. And that's all you really care about. And the reason for that is because you know that if you can really understand what goes in and what comes out, then you kind of understand what's going on inside. Because if I know 1 and 1 gives me a 2, then I can probably guess that there's some addition going on inside this black box. Or if I know 1 and 1 gives me, 3, then I know there's something going on inside of this black box. So we call this the black box technique. And this technique only focuses on what goes in and what comes out. Now, the opposite of this technique is what we call the white box technique. And what does this do? The white box technique is a technique that essentially follows what happens. I got a text from a student. Oh, okay. I thought it was outside or something. So the white box technique, it's basically we trace what happens inside of the software. What happens to my 1 and 1, right? How does it become 2? Something happens inside. I want to follow that trace. So this is the white box technique. Now, you need to be quite technical to use the white box technique, because you need to know some programming language. And the good news here is that a lot of you, the first few years in your career, you'll be doing the black box technique. Okay? And we have different types of black box technique. We have about 4 different types, or 5. The textbook has way more, but in the industry, we only use maybe 3 or 4 of them. So I'm only going to teach you the ones I use every day on the job. The first technique is what we call equivalence partitioning. I know, it's a very long name. I don't name this stuff. If I do, I'll call it something simple. But equivalence partitioning means if you have a group of inputs that is going into a software, and those inputs gives you the same output, then only take one of those inputs as a test. Let me repeat that. So equivalence partitioning is a black box technique that says if you have multiple inputs or a group of inputs going into a software and they all generate the same output, don't waste your time testing each single input. Just take one from it. So a perfect example is this. Let's say you've been hired by the city of Mississauga to build a bus fare calculating software. Okay? And in this calculating software, the BA gave me this requirement that says if the age of the customer or the person riding the bus is anywhere from 1 to 12, then this customer only pays $5 because he's a child. If the age of the rider is anywhere from 13 to 59, then this person pays $20. And if the age of the rider is 60 and above, then this person pays $10 because they are senior. That's the requirement the BA gave you, or in the planning meeting. That's what she told you. That guys, this is what I want the software to have. Now, as a QA, if you have no technique guidance or technique training, you might be tempted to test every single number here. If I was to ask you that, tell me your test. You might probably tell me, yeah, I'll test 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and you might pick, or you might just tell me randomly. I'll test 40, 60 randomly. But no, you don't have to be random. There's a technique that we use for this. If I apply equivalence partitioning, I know that the numbers from 1 to 12 will give me the same output. So it doesn't make sense to test all of it. Just pick one. So maybe I'll pick 7 as my test. So test 1, I will say verify the amount for age 7. Applying the same technique to my second group, I'll say test 2, verify the amount for age 40. And the last one, test 3, I can say verify the amount for age 80. Okay. Only 3 tests is needed. And this goes back to our testing principle that we learned yesterday that says exhaustive testing is impossible. You can't test everything. So you got to pick smartly and wisely. So this technique, will save you a lot of stress, a lot of time, and it's been known to work. So use it. All right. So the next black box technique is what we call boundary value analysis. Some people call it BVA. So same thing. Let's try the same requirement. So you're in an agile team. Your PO, gives you a story, and the story goes like this. And the PO said, okay, in the planning meeting, the PO told you that she wants the calculator to obey these rules. So if you apply your first technique, that gave you 3 tests. Now, what is a boundary value analysis? It's a type of black box technique that tends to pay emphasis to the boundaries of your inputs. And what it says here is, it says always take the value to the right-hand side of your boundary and take the value to the left-hand side of your boundary and also take the boundary. I said, okay, all right, so let's try it. So now applying that technique, I know that 1 is a boundary because that's the first one. So I know that it makes sense to test 0 because that's the boundary to my left-hand side. Now I'll take 1 as well. And the boundary to my right-hand side is 2. So I'll take 2. So now I have 3 more tests. Let's keep going. What's the next boundary? 12. So the boundary to my left-hand side is 11. I'll take the boundary, which is 12, and the boundary to my right-hand side is 13. So I'll take that as well. Now I have 3 more tests. Keep going. 13, the boundary is 12. I have that already. The boundary, to the left is 12, the boundary is 13, and to the right is 14. So I'm going to take that as well and call it 14. Going. Over here, I'm going to take 58, 59, and 60. So we can 58, 59, and 60. And over here, I would take 59, 60, and 61. So I have 59, I have 60, and I can take 61. But instead of 61 is entirely up to you. Some might say, okay, I want to take a 3 decimal number. It's entirely up to you. Okay. Now, these are my tests. I now have a complete set of tests. So my next test will be verify the amount for age 0. Test 5. Verify. Now you're becoming really one of us now. You're becoming a QA. Verify the amount for age 1. Verify. Test 6. Verify the amount for age 2. And it goes on that way. So these two techniques, in fact, we use them together most of the time. So EQ and BVA, they tend to go together. And by doing that together, I now have 1, 2, 3, 4, 6. Okay, I have 6, 7, 8, 9, 10, 11, 12, 13, 14, and maybe 15 test cases for this simple requirement or story. That's it. Okay, so let's move on. Now the next type of black box technique we have is what we call decision table. Now let me give you an example of this, then I'll explain how to use this technique to solve the problem. If we have, say, a vending machine, we have a PO that wants us to build a vending machine that serves drink at the airport. And the PO says, these are the requirements. These are the business rules I want you to make sure that the software does. Like, okay, tell me. And she says, if you are a male and you are a new immigrant coming to Canada, we give you coffee. If you are a female and you are a new immigrant coming to Canada, we give you tea. And if you are an old immigrant, we don't really care about you, we don't want to impress you, we just give you water. Okay, so this is the story. The team planned the story. Everybody voted. We said it was going to be a 2-story point. We started the sprint. Now I have to test this vending machine software. How will I test this? You know, what's the boundary of a male? It's not really clear to me what a boundary of a male is. Maybe a she, I don't know. I'm being recorded right now, so I can't make. Right? What's the boundary of a male? What's the boundary of a female? What's the boundary of a new immigrant? It's not really clear. And the reason is this. Whenever you have inputs that has 2 logical states, then you need to use the decision table. What is a logical state? A logical state is an input that can have 2 values, meaning the input can be yes or no. Input can be a new immigrant or an old immigrant. Input can be a male or a female. Even though this is not a good example anymore, because it can also be in between or unidentified. You know, there are quite a few out there right now for gender. Right? So we call this logical inputs. They are inputs that, you know, there is not just one way. Unlike the age where you're only 5, you can't be 5 or 10 years old. You're only 5. So this input only has 1 state. But whereas over here, we can, to the vending machine, someone can push a male or someone can push a female. And that's just for the gender. And also your immigration status, someone can push new or someone can push old. And that's just 1 input as well, but it has 2 different states. So whenever you see a BRD or a story that has this sort of requirement, then right away you know that you need to use the decision table. Let's break it down. Now the decision table goes like this. It says the number of tests you need is based on the number of inputs you have. And the number of tests is a formula that says number of tests you need is 2 to the power of our keyboard here. 2 to the power of x, where x is your number of inputs. Now, guys, let's imagine this is an actual real vending machine. I can tell you, if I was to draw the vending machine, and I'm not such a good artist, but I can imagine the vending machine to look like this. Maybe like the one in the office here. It's going to be a long box looking machine that would have, the first one will be, what is your agenda? And you can either select, there might be 2 buttons there just for the gender, and one will be M and the other will be F, right? And maybe another one, it might be your status, and maybe there'll be something like this as well. There'll be 2 buttons in there, and I might have new and I might have old. Okay, and on the bottom here we have a drink. The drink comes out. Enjoy a cup of coffee. Mind my drawing skills. Let's make it hot. Okay, so that's meant to represent steam coming out of the cup. Okay, so this is what a vending machine will look like. So you can see here my gender has 2 states, and my status has 2 as well. So that means the number of tests I need for that simple vending machine is 2 to the power of 2, which is 4. Because to the non-engineering people here, to the power of something means multiply that thing as many times in 2s. So if I say 2 to the power of 2, I'm trying to find the power. Okay, I'm just going to copy from here. So 2 to the power of 2 means 2 by 2. 2 to the power of 3 means 2 by 2 by 2. So now you can figure it out. If I have 3 inputs that are logical in nature, that means I have 8 different combinations, or 8 different tests. If I have 4 inputs, I have different logical states. It means I have 16 different combinations. Okay, so now let's try the first 2. So now we know that 2 by 2 is 4. So I know I need 4 tests. How do I get there? How do I know the test that I need? Some people, you can kind of do it common sense wise, which is I will be a male for now, and I will try male and new immigrant. Then I'll try male and old immigrant. Then I'll switch it to female. Then I'll try female, new immigrant, and I'll try female, old immigrant. And that gives me 4 tests. So that's good. I mean, you can do it that way as well to say, well, it's just easy. I would just say, verify what drink the user gets when you are a male and new immigrant. The second test is verify the drink you get when you are a male and you're an old immigrant. And test 3 is verify the drink you get when you're a female and you are a new immigrant. And the last one is verify the drink you get when you're a female and you're an old immigrant. Okay? Now, if it's 8, I can guarantee you're going to make a mistake. Because, it gets harder to start kind of freezing one, flipping the other one. Now you have 3 different inputs. So to make it easy for us, we actually have a table that we can draw that will show me all my tests. And we call that table the binary table. Like the binary table, because binary counts in zeros and ones. So that is a perfect table to use in this case. So now let's count to 4 in binary. So you start off with 0, 0. You go 0, 1. You go 1, 0. And you go, oops, is it changing it for me? 0, 0, 0, 1, 1, 0. And lastly, 1, 1. Make it cleaner looking. Oops. Okay, I'm just going to use, I'll use Excel for this. Yeah, I think it's easier to draw it in the table form. So I'll start off with 0, 0. Then I'll go 0, 1. And I'll go 1, 0. And I'll go 1, 1. And you need to know this. Once you memorize how to count to 4 in binary, you can count to any number you want in binary. It's pretty straightforward. Okay. Now, let me move this down a little bit so I have some room at the top. I can now decide that my first column is gender. My second column is my my status. These are the two inputs that are flipping. And lastly, the drink I get. Now, I will decide by myself that a 0 for gender, 0 for gender means you're a woman, and 1 for gender means you're a man. And I'll decide as well that a 0 for status means you are a old immigrant, and 1 for status means you are a new immigrant. Now, it doesn't matter how you do it. We'll get the same result. And the reason is we have the same number of zeros and ones. So if you notice, I have 1, 2, 3, 4 zeros, and I also have 1, 2, 3, 4 ones. So now let's fill up the expected result. So what drink will I get if I'm a woman and I'm an old immigrant? I will get water. That's what that's what the product owner wants. What drink will I get from the vending machine if I'm a woman and I'm a man? Then I get, sorry, you can't be a woman and a man. What drink will I get if I'm a woman and I'm a new immigrant? I get tea. What drink will I get if I'm a man and I'm an old immigrant? I get water. And what drink will I get if I'm a man and I'm a new immigrant? I get coffee. So once you have this table now, it's straightforward. Your test cases is straightforward. So my test 1 is just verify, the same thing again. Verify drink, woman, old immigrant. Test 2, and you can see that it's the same test I have here that we kind of came up with manually. Over here is the same thing. The order might be different. Over here, I started with a male, new. Over here, I started with a woman and an old immigrant. But you get the same test. So we call this the binary table. And the reason for the binary table is because it allows me to find unique, different combinations. That's the whole point of testing. Testing is all about finding those combinations that the regular user would not think about, right? Most people, if you're a non-trained person and I say, can you test this vending machine? What you most likely do is just, select the one you are. That, okay, I'm a female and I'm an old immigrant. Most people just run 1 or 2 tests. But as a QA, you want to test every single combination. Now let's try 3. What if I had 3? Let's make this vending machine slightly more interesting. So let's say this vending machine has 3 inputs. Okay. And let's say the third question they're asking you is if you've maybe received your vaccine, right? We want to know, anyone coming to the country, are they vaccinated or not? So the answer here could be maybe yes or no. Or no. Okay. Now this is slightly more complex, and you can't just, freeze this guy, and kind of flip this one. It gets messy. But you can still do it, but it's way much easier to use your binary table. Let's try a binary table. In my binary table, I know that 2 to the power of 3 is 8 because 1, 2, 3. So that's 2 by 2 by 2 in 3 places. So that's 8. So I know in my mind I have to count up to 8 in binary. So how do I do that? First of all, you count up to 4 in binary. So let's say we remove all this and we have another column for vaccine. Okay. So I'll first of all count till 4 in binary, which is essentially 0, 0, 0, 1, 1, 0, and 1, 1. Then what I'll do is I'll copy everything from the top. Sorry, this should be in the last 2 columns. So cut this and put it here. There we go. So don't put it here. Something else is coming here. You should go in the last 2 columns. So now I'll copy this and I would paste this to the bottom, the exact copy, just paste it to the bottom. Then where you're copying from, you add zeros to it. And where you're copying to, you add 1 to it, just like that. And voila, we found every unique combination for 8 different states. It's as easy as that. Same thing if you have 4 inputs, that would be 2 by 2 by 2 by 2, which is 16. So same idea here. I have 8. I will just copy my entire 8 block. So if I had 4 inputs, maybe this is religion. Maybe you are a Christian or you're non-Christian. So what I'll do is I now have 16 to go. I already have 8. So I'll move, first of all, you move this 3. You move them to the last 3 columns. Okay. Then I'll copy the whole thing from there and I'll paste it down. And where I'm coming from, I'll put zeros. So you need 8 zeros. And where I'm going to, I'll put ones. So I have my ones. Voila. Now right away, I have unique 16 different combinations. And that's how we do it. Okay. So this is how you model if you're trying to find different combinations. And you would always find this technique to be useful. You always find it to be useful. Let me show you a requirement I'm testing right now for the government. And I just want to show you a table that they gave me in that requirement. Okay, good. So I have a table here that I have to test. And, a new QA might be overwhelmed that, oh my God, how will I verify? So this is a BRD given to me. It's a waterfall project. So the BA went before everybody else. And the BA is Patrick. You can see his name. And he actually modeled, he got the requirement. And it's telling me, Ty, please verify that this execution order exists. And there are 30 of them. Look at that. There are different types and different shapes. So for me, I know that there are so many combinations that can happen. But then again, I can't do 2 to the power of 30 or 2 to the power of 31. That would mean a million tests, which is not possible. So what I do is I break it down, right? So I might maybe take this group, maybe groups of fours, right? I might take the first four, model that, find the unique combination, take the next four, model that, find the unique combination, and keep going that way until I have a sense of, okay, I've hit most of it. Okay? So this technique will never leave you. You would always be using this technique because as a QA, you want to find, you're getting paid essentially to find all those unique different combinations. Okay, so that's good. If you have any questions, please, you can always slow me down or you can message me on the app. So we've spoken about equivalence partitioning. We've spoken about boundary value analysis. We've spoken about decision table. And the next one, I'm going to skip this one. And the reason why is we don't use it. I've never used it in my career. If you want to read about this, please go into your textbook and read about this. But I haven't used it, so you can skip it. The next technique that we tend to use a lot is what we call the use case technique. And the use case technique is a different approach to the first three because it doesn't really care about the input. Even though I told you, the black box is all about the input and output. Yes, similar here as well, but the emphasis here is on what the system does. So the use case technique is what does the system do? The use case techniques helps me find what the system does and who does it. And typically, we represent this by giving you a diagram. That's the easiest way to explain it. So we have what we call a use case diagram. And BAs love to always give us requirements in a use case diagram. So as a QA, it's really important that we know how to get a test from that diagram. So let's go back to your class notes. I sent you guys a copy of like an example of what a use case. Good. So here is a very similar example of what a use case diagram looks like. In the use case diagram, there are three things you have to be aware of. The first thing is the system itself that we're testing. The system is represented by a box. This little box, that's the system. What the system does is represented in a circular shape, which we call a use case. So a use case is what the system does. And who does it is represented by a stick man like this. So now, if a BA gives this to you in a planning meeting, your job is easy. You can get your test. They're jumping right at you. So your tests are the solid lines that are drawn. Those are your tests. That's your test. So my very first test will be verify that this guy can do this. My next test is verify that this guy can do this. Verify that this guy can do this. 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 Verify that this guy can do this. It's a lot easier, right? And that's why BAs love it. They know that by giving you this diagram, it saves them a lot of typing, a lot of explanation. Everyone gets exactly what it is they have to verify. But we're not done. Those are the positive test cases, the solid lines. So let me take notes of that for you. So the solid lines in a use case diagram is your positive test case. Now the lines that are not drawn, so the undrawn lines, are your negative test case. What does that mean? Let's go back to the diagram. The negative test case is verify that this guy cannot do this. Verify that this guy cannot do this. Verify that this guy cannot do this. Because don't forget, you're getting paid to verify the positive workflow, but you're also getting paid to verify the negative workflow. Because we need to know how the system will react. If this guy tries to do what he's not supposed to do, is it going to crash the system, or are we going to display a very nice and polite error message? Okay, so the use case diagram is a favorite amongst waterfall BAs or agile planning meetings. POs, they like to represent requirements using the use case technique. Now you might ask me, Ty, what is this broken line here? Sometimes some use cases, as a result of running the use case, another use case happens. So that's a dependency. And let me give you an example. In this case here, I'm going to make it bigger so you can actually read it. So we have somebody called a client service rep. The client service rep can manage something. And whenever he manages that thing, we typically generate a notification, which could be an email or a text message or something happens. Okay. Now, we also have a requester that can request for something. And whenever he requests for that thing, we also generate a notification as well. So these two use cases are dependent, or this use case rather is dependent on two other use cases. Some QAs like to make this also a unique or a separate test, which is verify that a notification is generated when a client service rep manages blah, blah, blah. That's good. Same thing happens here. Verify that a notification is generated when a requester requests a temporary override. That goes as well. Some QAs like to make it just one test case. Everybody has different styles. So maybe one test case will be verify that a requester can request a temporary override and a notification is generated. Verify that a client service rep can manage a client consent directive and a notification is generated. So the same thing, but it doesn't matter how you break it down. It's really up to you how you do it. But these are a test. So now looking at this diagram, I have, let me make it smaller again so we can count. If I was to count how many test cases do I have? Positive, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 positive test cases. Negative, I have 1, I have 2, I have 3, I have 4, I have 5, I have 6. Okay, then this guy I have 7. Is a lot, right? Negative is quite a lot. So I'll stop there. But you get the point. And also, use some common sense. If you notice, positive you have, I think we counted 9, and negative you have 35. Please don't take all 35. Just kind of ask the product owner, which one is most likely to happen, because you can't test everything. And the idea is not to test every single combination out there. Okay? But as you can see, we have quite a lot of negatives. Okay. So that's the use case technique that helps us. But if you notice, guys, that the use case tends to be at a very high level. It's a high level technique, because I can guarantee you that this generate report, when you go deeper into it, you might actually use your other 3 techniques. Meaning now, okay, when I start testing this, what does it mean to generate a report? Does it mean I have to go to a form and put in my name, put in my email address, then say send? Now, if that's the case, then once I see that form, there are many more tests that I can do to that form or that page. So that's why we always say in testing, this seems to be the technique most of us start with. We tend to start with our use case technique. It's provided to us. Then from our use case technique, we tend to move on to the other black box techniques. See if that would work. You get it? So you start off with your use case technique. You want to kind of get the big high level test cases. Then from there, you go deeper. You now pick one use case, and you now see if you can apply your BVA, your DT, and your EQ. And in your coursework for week 2, I expect the same idea from you, where you look at a problem, you can apply a mix of combinations. Now in class, a lot of you always ask me, Ty, do I need to apply every technique every time I see a requirement? Or how do I know which one to apply? And I go, there's no right or wrong way to it, to be honest. There's no right or wrong way. What matters is you find the most bugs in the system, most defects, you find them. How you find them, we don't normally care, but this techniques helps you think about different combinations and different ways of testing that will allow you to find better defects. Okay. So that's the the 4 techniques, the black box that you use all the time on the job. And please, guys, when you go for an interview, they'll ask you, how do you generate your test? Please don't say what everyone says. Oh, I read the business requirement document and I get my test magically because I'm God. It just comes to me, right? Or some people say, well, I go to the planning meeting and I just get that's it. I get the requirement, and the requirement, I test it. No, that's the bare minimum. Just testing the requirement is the bare minimum. As a QA, you need to take that requirement and think of many different possible combinations, many different possible scenarios. And so you tell them in an interview, well, once I get the requirement, I have 4 types of black box technique that I use. The first one I use is my BVA, which allows me to pick one of the inputs when I have similar inputs. The next one I typically use is my boundary value. That allows me to focus on the boundary and pick the boundaries of my inputs. The next one is my decision table. Some inputs are logical in nature. They have 2 states. So I tend to find all the different states and the combination of states. And lastly, I know that the use case technique is a very popular technique used by the business analyst or the product owners. So when I have a use case diagram, I can easily get my positive and negative tests from the diagram. Now you sound really good. You sound like one of us. Okay? So that's how we think. And doing your coursework this week would allow me or Deep to know if you're applying those techniques. Alrighty. So we're almost done. The next one is what we call static analysis. And this is the white box technique I was telling you guys about. I will skip this as well because you're not going to use it. But for anybody curious that, okay, how do you do a white box technique? Then you can go read the textbook. They explained, there's a lot of chapters that really explains what this means, static analysis. But essentially what they're doing is they're going through the code. You can inspect the code and you're following is a trail. You're following the trail. And every trail you follow, there might be what we call decision points, where the software has to make a decision. and the software can go either left or right, and you basically follow both of them. You say, okay, it got to a decision point, it's going left, I'll follow it down that path, and I'll see what happens. You come back, and you say, okay, I'm also going to follow it down the right path and see what happens. And that typically comes from when you understand some programming. So before we wrap up, the last topic in this class is test cycles. So I know, Taryn, you have to go, but yes, you can go, Taryn, if you have to leave. I would keep recording, and I'll send it off to you as well. Oh, actually, you said 8:30. Oh, good. We have time. 8:30. Never mind. I thought you said 7:30. Okay. So our last topic, guys, is what we call test cycles. And test cycles is the different types of testing you'll be doing on the job. So you get a job today. These are the different types of tests that we do all the time on any project. It could be a Scrum project, a waterfall project. All QAs are in one of this cycle at any point of time in their careers. So the first one, let's break it down. The first type of testing that we mostly do, or that we are part of, is what we call unit testing. Now, what is unit testing? From the name, you can tell it's the smallest unit, is the smallest measure of test that the team does. And in fact, we don't do it. Developers do it. And what they do is, let me go back to my diagram. This vending machine, I can tell you, is made up of different lines of code. That's all it is on the back. On the back end, there'll be a small little computer chip that has, I don't know, maybe thousands of lines of code that is controlling this vending machine. Now, those lines of code, they have different sections. There'll be different sections of the code. So the unit test is basically making sure that every section has a self-check, like a self-health check. Every section has a little tiny health check to make sure things are okay. So same thing here as well. This little guy here would have his own self-check. And the thinking of this, or why we agreed to do this, is because we think if this self-check fails, the entire software fails. And that will save QA's time from finding the same bug. So that's why we QAs always enforce it on our team to say, developer, please always make sure that before you send me a story, right, before you move it from to do to in progress to be verified by QA, please make sure that you've done your unit test. They don't like doing it because it adds more time to their work. Some of them complain doing it, but we QAs always enforce it. Okay, so that's what we call unit testing, and it is coding. So that's why we don't do it as well. You need to understand, those block of codes, and you need to go in there and think of a good self-check that you can put in that block of code. Okay. Now, the first one that we start off with is what we call functional testing. Functional testing, as the name sounds, is where you're verifying the function of the component of the system, which I've been calling small chunk or little chunk. Imagine we're trying to build a car. We've divided the car into 5 different chunks. Each chunk that you're verifying or you're testing, you're doing what we call a functional test. So it is where you're verifying the function of the system. And the function, is those little chunks that we've broken down using the Scrum life cycle. So we call that functional testing. And QAs, this is where you're going to start your career from. You join a company, you get a job as a QA, and right away you might start doing functional testing. Now, when the little chunks have all been tested and put together to form the product, we do one final testing on that product, or maybe several testing. We call that system testing. Some people call it end-to-end testing. Means I'm now testing the entire functionality of the system. But it's not just the little guy or the little chunk, it's now the entire system that I'm testing. So we call that system testing. And we QA spend easily 60% of our time doing this. This takes most of the time on a project. So you spend 60% of your time on a project doing system testing and functional testing. Okay. The next type of testing that we do in this profession is what we call the system integration testing. And what does this mean? System integration testing is where we test how other systems affect the system that we have just tested. Some people call this SIT. IT guys are lazy. We're all very lazy in IT. We have short forms for almost everything. Synonyms or anonyms. So you might hear the word, guys, tomorrow we're starting SIT tomorrow. So they're trying to tell you tomorrow we're starting system integration testing. And the idea here is we're not trying to find functional bugs or functional defects because you've done that already here. So we actually assume by the time we start system integration testing that the system is somewhat free of defects. And what we're trying to find out is how does the interaction of my system under test, so it's a system under test, how does that interaction affect the other systems around it? Other systems can mean maybe your database. It can mean maybe a payment gateway. Maybe you're accepting credit cards from PayPal on your website. So you probably connected, your website is connected to PayPal. So you want to see how PayPal would affect your system. Maybe you have a firewall that your company installed. You want to see how the firewall affects the system. So there are many, many other systems, that talk to your system. And the good news here is the test is really easy. You don't have to crack your brain. Yes, for functional testing, you need to use your techniques. You need to use your design techniques, your black box. But for system testing, the test is the same every time. Well, not every time, but most of the time is the same. And what do I mean by that? What I mean by that is I will basically turn on my system and I will turn off the other system. And I'll see how my system reacts. So I have Facebook, and Facebook accepts credit cards on PayPal. What happens if PayPal goes down and we have a Facebook user that is trying to buy something? How does it affect Facebook? Then I'll switch it around again, vice versa, to say what happens if PayPal is trying to send us something and Facebook is down? What happens? And we do the same thing for the other systems. So it's exactly the same. And if I can show you one of my test cases at work, you guys can see my integration right here. Look at this. This is my integration test cases. Let's see what it looks like. Now see, shut down, send something, verify that those things you sent is not lost. While it's shut down, turn it back on and ensure that everything now makes it to the database, do a count, make sure that before and after, nothing is lost. Shut down, turn off, shut down, restart. That's all we're doing. Verify that nothing is lost when the database is down. Verify that nothing is lost when this other system is down. Verify that nothing is lost when AMQ is down. So they're all the same type of test that we do. Verify that the system displays a nice error message when something goes down. It's all about something going down and something coming back up, because we know that it's not a perfect world. Things will go down, right? So you want to see how something going down, what effect it has on your system. We call that SIT. Okay. The next testing, the next type of test that we do in this profession is what we call performance testing. And what is this? Performance testing. Performance testing is the test we do to measure the performance of the system. When we start hearing performance of the system, we're actually trying to describe to you time is a component of time. So we're trying to tell you how long, how quick is the system. Yes, I can have a system that is free of functional defects. That means it works. I can have a system that is free of system integration defects. That means, when it goes down, it saves everything nicely. When it goes down, it shows a nice error message. When PayPal goes down, nothing bad happens. That's good. But you could fail performance, meaning your system could be slow. And that's also not good. And if you remember yesterday, I told you one of the reasons why we test is to also ensure for performance, to make sure that the system is fast. And we have a separate class for this because we can't take this in 1 week or 2 weeks. It's a separate niche of testing. And if you're interested in this, let me know and I can put you into that class. So it's a separate side of testing. But there are two things we measure here in performance testing. We measure the response time and we measure the transaction per second. Response time is typically measured in milliseconds because that's how fast computers are. Millisecond is 1,000. 1 second is 1,000 milliseconds. So that's how you see how small we're measuring it. And TPS is typically measured, is just transactions per second. So you might have the word maybe 5 TS or something like that. What is a response time? If I'm trying to log into Facebook, the response time is the time it takes Facebook to take my username and password and show me something else. Maybe show me my newsfeed page. That time, we measure it and we call that the response time. The TPS is transaction per second. A transaction is when I send Facebook something and Facebook responds back to me, that to and fro is one transaction. And we always want to know how many transactions can a system handle in 1 second. And the higher it can, the more users you can actually have on your product. The higher the TPS, it means the more users you can have. Because I can guarantee you there'll be a time where there'll be thousands of users doing the same thing at the same time. So we want to know how the system will behave. And we call that TPS. And the idea here is also when you're doing performance, we assume that the system is free of defects. In fact, it has to be free of defects because a defect could be the reason why the system crashed, why it's not responding. So you don't want to fail, you don't want to raise a performance defect when really is a functional defect. So that's why performance tends to happen much later down the life cycle, once we know there are no more functional defects and there are no more system defects. The next one, we're almost done. The next one is what we call user acceptance testing. So user acceptance testing. And this is a type of testing we do where we invite the business analyst or the product owner or the end users to come and test the software themselves. So play with it and let us know if they're happy with it. It's a very waterfall approach because in Scrum, we don't really need it. Or you can say we do this every time we're doing a review. Every time we're doing a demo meeting, we're essentially doing a UAT. But in waterfall, where we've gone a year, to build a product, or maybe 6 months to build a product, yes, it makes a lot of sense to invite the stakeholders at the end of your testing or the end just before you ship to come see it. Some companies call this beta. They call it beta testing. So you might start hearing the word, or you might see it in job requirement. You're looking for a QA that has experience in beta or alpha testing. Call the product before we ship, we call it beta or alpha. It means that, okay, this product is very, very close to the final thing, but it's still not yet ready for the customers or for public use. Some companies pay you, mostly game companies, the PlayStations, the EA games. Whenever they design a new game, before they ship it, they'll run an ad saying we're looking for 10 kids or 10 adults to show up to come test this game for us. And we'll pay you, $50 for the entire day. What are they looking for? It's the same thing. The QAs have done the functional, they've done the system, they've done the performance, and now just before we ship, we want to make sure that the actual end users, they're quite happy with the system. Okay. Now, what do you do here? Because when you see the job that says you're looking for a QA that has experience in user acceptance testing, which we also call UAT, what do you do here? There are two things you do here. The first thing is training. And that's what they're looking for when they're posting those jobs, saying we're looking for a QA that has experience. Because you want to train, out of anybody in the room, you're probably the last person that's played with the software or that's tested the software or has used the product. So that day, you'll be there to guide the beta users or the UAT users on how to navigate, on how to use the software. The other thing you do during UAT is you provide some test data. You provide test data. So providing test data, because you out of everybody probably has the most combination of data. You probably have 1,000. You probably have 1,000 test cases. So you have 1,000 Facebook emails, 1,000 Facebook passwords. Each email and password is for a different reason. So that day we want to save these guys a lot of time. So they will use your data. And lastly, you're biting your fingers, hoping that they don't find no bugs. Okay? Doing UAT is very, very costly for a team to find a bug during UAT. In Scrum is okay. It's only a 2-week cycle. So maybe doing your review, the PO says, oh, I'm not happy with that. It's okay. It's only 2 weeks of work. But in Waterfall, yeah, that might be quite embarrassing if they find, a big bug during your UAT. Then another type of testing we do is what we call regression. Regression from the name means to go back. So when I say regress, it means you're going back. And what does this mean? I told you guys yesterday that, when you run a test for the first time, maybe your functional test. So you do your functional test for the first go. You ran 50 tests. Your 50 tests found 10 defects. Very happy man, relieved man, like, yes, I'm doing my job. The developers or the team will fix those 10 defects and they will send you a new version. Maybe you tested version 1. You found 50 problems with 10 defects. Now they will send you version 2. And when you get version 2, please don't be naive, and think, oh, I've done the test before, so I'm just going to, I'm just going to move on. or I'm just going to verify that this 10 defect has been fixed. Yes, you have to do that. So the first thing you probably do is you retest the 10 defects. Make sure that it's been fixed. Now, once you're happy that all the defect has been fixed, then you have to repeat the test again. You have to repeat the 50 tests you've just ran. And this is the boring part of our job. This is the only part of our job that I don't like myself, because, you can do this probably quite often. Maybe as you're doing this, you found 2 more defects. So you know that there will be a version 3. For every new version that there is, you have to regress. You have to run your test all over again. And that sucks, but the reality. But now we can apply a principle to help us. We can apply the defect clustering principle while we're doing this. Right? Defect clustering says, these 10 defects were probably found in a particular area of the system. Maybe a particular component was the one that is so faulty or so badly designed that is causing a lot of failures. So in your retest, it might not make sense to run the entire 50 again. Maybe only focus heavily on 20 or 30 and test lightly the remaining 20. That's you now applying your techniques, your test principles. I told you yesterday, those test principles are there to guide you and save you time. So this going back, running the same test all over again is what we call regression testing. And also, if you apply another technique, which we call the pesticide paradox, I told you that yesterday, you should know that if you keep running the same test over and over and over again, one day will come where this test will become useless, right? It means that the system is now immune to your test. So QAs generally, in a period of 1 year, they change a few things. Some might not change the test, they might change the data. Some might not change the data, they might change their path. The way they sign into Facebook. Maybe they always use username and password combination. Maybe, next month they try email and password combination. It's all about the pesticide paradox. You're adding a new surprise every now and then, a new flavor to your test. So we call that going back regression testing. So we have 2 more to go. Now, the good news here is this. Oh, how can I forget this? 5 years ago, because of Agile, we introduced automation. And you cannot get a job today in QA if you don't have some automation skills. And what is this? Companies realize that QAs spend the bulk of their time doing regression testing. They realize that let's think about it. 50 tests took you 3 days to run. Okay? At the end of 3 days, you found 10 problems. They fixed it and gave you back a new build or a new version. You ran the same, 50 tests again, and you also burned 3 days again. And you found 2 problems. And they give you another version. Then you run the same test again, another 3 days is gone, and maybe this time you find no problems. That's almost 9 days of going back and back and back and back and back. And at this point, you're probably fed up as well. You're probably bored. So Agile, in Waterfall, it was okay because we had a year or we had 6 months. But guys, every 2 weeks, you can't be doing this. There's no time. It's a sprint. It's a race. We're moving fast. So what these guys said is, why don't you automate your retests? And that's why there's a sense of renewed energy in this profession right now because of automation. We all love it. The boring stuff, give it to the computer to automate it for you. So we call that automation testing. I'm going to teach you this. We're going to spend 5 weeks on this, automation testing. And the reason why is because it's so key, it's so important. And is that retest. Anything retest, we automate it, so we save time. Now watch the beauty of automation. If I spend 3 days, computer will not spend 3 days. Computer, it can run 1,000 tests at the same time without taking a break. So maybe a computer will only take 3 hours to test what I would do in 3 days. Every time I'm going back now, the company doesn't need to spend 9 more days for me just doing things manually. I can reduce the other 3 days to 3 hours. Then maybe I would do okay. Maybe I would do 1 day of manual, just check it. Let's say a human being checked it. Now that makes a lot of sense to the company. 9 days has now been reduced to maybe 4 days of work. You're saving money. So we call that automation testing. And that's because Agile was introduced. The next one, before the last one, is what we call smoke testing. What is smoke testing? Smoke testing, it's a subset of your regression testing. And the idea is this. It can be really frustrating that after the third day, maybe you were running your version 2, and after the third day, you're tired, but you notice that you found probably 40 defects. Right? Like something just ain't right. Something looks really weird. A junior QA will be happy that, oh yeah, good. I'm finding some good bugs. I'm excited. I'm doing my job. They're going to give me a raise. Right? It's happened to me before too. Then someone tells you that, oh, sorry, I didn't give you a version 2. I actually gave you a version 1 again. There's nothing more tiring than knowing that you have to repeat the same test all over again, and all your 40 defects that you logged, that probably took you a lot of hours to describe it and log it, is all useless. It's very demoralizing. So that's why we introduced what we call a smoke test. Some call it sanity. And it's basically pick some test cases out of your 50, maybe pick 5 or 10, or you will know the critical ones, maybe 5. And you will always run those 5 first. And if those 5 fails, then you know that, okay, this is a bad build. There's something wrong with this version. And you tell the developer, hey, my smoke test is failing. I can't carry on testing. And they will know what that means as well. When you say, hey, my smoke test is failing, I can't carry on testing. The textbook sometimes tries to tell us the difference between smoke and sanity. Guys, I've been in the industry for over 12 years. It's the same thing. Okay, we call it smoke. Some call it sanity. So don't get confused by the textbook's definition. The last one is what we call exploratory testing. And this is what they're trying to make you do here is also they're trying to make you do the pesticide paradox. They want you to change your approach to testing. So exploratory testing is a mouthful, is testing without using your tests or your test cases. You're not looking at it. You're not using it. The idea is you're freestyling, right? You're just playing with the software. So you open the software and you just push all the buttons, push anything you want, do anything you want, and see what you will find. And it's the same thing they're trying to make you do. They're trying to make you change something. And guys, that's it. That's every type of testing that we do in this profession. Some might say, what about mobile testing? Mobile testing, you're also doing either functional, you're doing SIT, you're doing performance, is all the same thing. So mobile testing is not actually a type of testing. It's just a device that is mobile, and you do these type of testing on the mobile device. And that's the end of week 2 as we know it. Now, if you want to read the textbook, you can read chapters 2, chapters 3, and chapters 4. And that explains to you everything I've just explained to you in more detail. I think they went a little bit detailed on that. So that's the end of the class. I'm going to turn off recording so that now that I want to hear your voices, everyone has been quiet. But yeah, let me turn off recording so we can chat.